Welcome everyone in the class of statistics. Today we will learn testing of hypothesis about the population variance. But before going to the details of the procedure, let us discuss the need of this hypothesis testing. Basically, this hypothesis testing is done by quality control managers in the manufacturing companies of equipments and parts. जो इक्विपमेंट्स और पार्ट्स प्रोड्यूस करती हैं ऐसी कंपनियों में उन इक्विपमेंट्स और पार्ट्स की वेरिएंस को चेक करने के लिए ये हाइपोथेसिस टेस्टिंग का यूज होता है. पार्ट्स की वेरिएंस का चेक करने से मतलब है जो पार्ट्स की थिकनेस है हर जगह इक्वल होनी चाहिए. ऐसा नहीं है कि वो पार्ट कहीं से ज्यादा थिक हो और कहीं से थिन हो जाए, तो दैट पार्ट्स विल नॉट बी फिटेड इनटू द एक्चुअल मशीन. एक्चुअल मशीन में वो पार्ट फिट नहीं हो पाएगा, तो दैट इज कॉल्ड द डिफेक्टिव पार्ट और डिफेक्टिव इक्विपमेंट. फॉर एग्जाम्पल, मान लीजिए कोई कंपनी वायर प्रोड्यूस करती है पर्टिकुलर थिकनेस की. उन वायर्स की जो वेरिएंस है थिकनेस में वो हर जगह सेम है या कुछ पर्टिकुलर पॉइंट तक वो वेरिएंस अगर मिलती है तो वो एक्सेप्टेबल है कुछ पॉइंट तक. लेकिन अगर वो उस वैल्यू से ज्यादा एक्सीड कर जाती है तो मींस वायर जो प्रोड्यूस हो रहे हैं वो डिफेक्टिव प्रोड्यूस हो रहे हैं. मींस मे बी द वायर that is producing may be very thick from one end and very thin from other end. In that case that wire is not acceptable. तो वायर्स की जो वायर्स प्रोड्यूस होके मिल रहे हैं उन वायर्स की क्वालिटी को चेक करने के लिए उनके लिए हाइपोथेसिस टेस्ट की जाती है, उनकी वेरिएंस, उनकी थिकनेस में वेरिएंस को चेक करने के लिए. तो ऐसी जगह इस हाइपोथेसिस टेस्टिंग का बहुत यूज होता है. So there are many other areas where the variance is very important. We are not going into the details of that. Let us come to the main point, which is the procedure of testing of hypothesis about the population variance. And the procedure starts from the step number 1, which is stating the null hypothesis about the population variance. So null hypothesis is sigma square is equal to sigma naught square. That sigma naught square is the assumed value, that is a fixed value, and or this is called the hypothetical value. Step number 2 is alternative hypothesis, which may be any one of these types. Step number 3 is set label of significance. Step number 4 is compute the value of test statistics. The value of test statistics is obtained by chi square, and that is equal to n minus 1 s square upon sigma square, where degree of freedom is n minus 1. S square is the sample variance and sigma square is the population variance. N is sample size. After that, we find critical value and mark critical and acceptance regions. Step number 6 is compare the computed value of chi square with that of its critical value. So steps are very clear to in understanding. For more clarity, let us take one example. Suppose we are given these data points and the hypothesis that we test is about the variance of the population that is sigma square is equal to 25. It is assumed that the variance of these data points is 25. We want to check this claim. So at 10% level of significance. So null hypothesis is sigma square is equal to 25 and alternative hypothesis is sigma square is not equal to 25. Simply we want to check the whether the variance is equal to 25. So we put the not equal to sign here. If we want to check that the variance of this data points is greater than 25 or less than 25, then we would take here greater than or less than sign. Alpha is 10% given. Sigma chi square is n minus 1 s square upon sigma square. And this n minus 1 s square is equivalent to summation xi minus x bar square divided by sigma square. The calculation is not shown here. The value is 16.84 of chi-square. Next, we draw critical and acceptance regions. Because this is a two-tail test, so critical region will be on two sides. One is towards the left hand side and another is at the right end. Because this is the chi-square distribution is not symmetrical, its shape is like this. So the thickness of the area, or the area that is looking here is not symmetrical. But the area is, this area is 5% and this area is also 5%. We divide this 10% into two parts. This area is 5%, so chi-square value is denoted by 0.05, 15, where 0.05 is the area towards the right hand side of this value and 15 is the degree of freedom. So when you look into the table, the value will be 24.9958. And similarly, this value is denoted by chi-square 0.95, 15, because the area to the right hand side of this value is 95%. Always we take the area to the right hand side of chi-square value. This is degree of freedom and that value is 7.26. So you can see that this 16.84 lies between 7.26 and 24.99. So it is coming in the acceptance region. So null hypothesis is accepted. Hence, we can say that the variance of this data values is 25. Next example is, it is believed that the precision of an instrument is no more than 0.16. The precision is in terms of variance. Write down the null and alternative hypothesis for testing this belief at 1% level of significance. For this given set of values of measurements that is done on the same object by the same instrument. एक ही ऑब्जेक्ट पर एक ही इंस्ट्रूमेंट से ये 11 ऑब्जर्वेशंस लिए प्रेसिशन मेजर किए गए हैं और वेरिएंस मेजर की गई है उस ऑब्जेक्ट की, तो हर बार उसकी वेरिएंस उस इंस्ट्रूमेंट ने डिफरेंट दी है। लेकिन हम ये क्लेम कर रहे हैं कि जो वैल्यूज उस इंस्ट्रूमेंट ने दी हैं वेरिएंस की, ये वेरिएंस में, इन वैल्यूज में जो वेरिएशन है, जो वेरिएंस है, वो 0.16 से ज्यादा नहीं है। तो we take the null hypothesis as sigma square is equal to 0.16 and alternative hypothesis as sigma square is less than 0.16. No more than means less than. Alpha is 1%. So chi square is n minus 1 s square upon sigma square. Here is the calculation of n minus 1 s square, because n minus 1 s square is nothing but summation xi minus x bar whole square. So we have computed this value in the third column. And the value is 0.1891. So you can put here this value, and the value of sigma square is 0.16. And this value comes out to be 1.182. Now we draw critical and acceptance region, because we have this is left tail test. So critical region lies towards the left hand side, and this is the acceptance region. This area is 1% and this value is denoted by 0.99, 10. 0.99 इसलिए लिया गया है क्योंकि the area towards the right hand side of this value is 99%. So from table this value is 2.55. So 1.182 is less than 2.55. It is coming in the critical region. So null hypothesis is rejected. That means जो मेजरमेंट में वेरिएशन है वो 0.16 से ज्यादा का नहीं है, राइट? Null hypothesis reject means alternative hypothesis will be accepted. So this is what is called the testing of hypothesis about population variance. Thank you very much for listening me. If you liked my lecture, please share it and subscribe my channel also. Thank you once again.